of imaginary numbers. Imaginary numbers. Imaginary number is I equals square root of -1. All right. If you put square root of -1 in the calculator, it gives you error. Most calculators cannot deal with imaginary numbers, so you have to know how to do this without the calculator. All right. So, but it's only the negative that makes it imaginary. If I have some other number in there, we're going to separate it. In our first example, we have square root of -52. Square root of -52. So what you're going to do is take the negative sign out. That's going to make it I times the square root of 52. And then deal with the square root of 52. For 52 is 2 and 26, 2 and 13. There's a pair of 2's that's going to come out. So we're going to take that out. So it's 2I root 13. And that's the answer. So the only thing that's different from what we've been doing is you deal with the negative sign first. Note, you must deal with the negative sign first. No matter what the situation is, you must deal with the negative sign first. Take the negative sign out, put an I in the problem, or I is part of your solution, and then deal with the rest of the problem. So that's example 1A. Let's look at example 1B. So we're going to take the negative sign out, making it 5I root 54, and then deal with the 54. So 54 is 2 times 27, and 3 times 9, and 3 times 3. So there's a pair of 3's with 2 and 3 left over. So this is going to be 5I times 3. The pair of 3's comes out, and then the 2 and the 3 stay inside, so they're going to multiply to make 6. So my final answer is 15I root 6. Right? So everything is normal. It's not that new. The only thing that happened was the negative sign came out as an I. That's all that happened. Let's go with C. Now don't confuse the negative sign on the outside with the negative sign on the inside of the radical. The negative side comes out, but it doesn't come out as a negative sign. It comes out as an I. And then deal with the square root of 8. Square root of 8 is 2 times 4, 2 times 2. So that's going to be -4I times a pair of 2's come out. So it's 4I times 2 with 1, 2 left over, 2 inside. Multiply the two numbers you have on the outside. So it's -I square root of 2 and -8I square root of 2. And that's the answer. Okay, now there's I has a weird property. Okay, what happens is, when you square 1 or raise 1 to any power, it stays 1. Same with 0. If you raise -1 to a power, the odd powers are positive, the even powers are negative. I has a similar property. It's just a little more complicated. There are 4 different results when you raise I to a power. I to the 0 is going to be 1. I to the first is just I. I squared is -1. I to the third is -I. All right. Now, so what am I saying here? What happens is you have other powers. We're going to come back to this in a moment. I'm going to ignore that for now. I'm just going to do some examples on the side here. If I have I to the, say, the 10th power, okay, I to the 10th power. All right, I to the 10th power is the same as I to the 4th times I to the 4th times I to the 2nd power. Right? So what does this mean? I to the 4th, I to the 4th, I to the 2nd. Well, let's look at what I to the 4th is first. So I to the 4th is same as I squared times I squared. And I to the 4th is I squared times I squared. And I have I squared. So now all of these are I squares. Okay? But what's I squared? I squared is -1. Right? I squared is -1. That's something that's you're going to have to know. If you're wondering why is I squared equal -1, let's remember what I is. Right? Remember up here, I equals square root of -1. So what I'm doing is squaring both sides. What happens when you square a square root? Right? When you square a square root, it cancels the square root, so you just have -1. So that's why I squared equals -1. And I have a bunch of I squares here. I squared -1, -1, -1, -1, -1. So these are normal numbers. They're just -1. So there's what? 1, 2, 3, 4, 5 of them. So when you multiply it out together, you get -1. Okay? So what has this got to do with anything I have over here? Okay, my point is, well, let's step back a little bit first. So I to the fourth was two of these, right? I to the fourth was two of these I squares. What's negative 1 times negative 1? Negative times negative 1 is positive 1. So that means all these I to the 4 are equal to 1. So what's important is what's left over. I squared, remember, is negative 1. So if I take out all the multiples of 4 out of an exponent and I just look at what's left, that's going to be one of these four choices. Okay? All right. So that's why it says up here to divide the exponent by 4. And if the remainder is blah, 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 then it's one of these. Okay? So here, what is 10 divided by 4? And look at the remainder. So 10 divided by 4 is 2 with remainder of 2. If you do long division, you can do it this way. You do 4 divided by 10. I'm sorry, 10 divided by 4. 2 times 4 is 8. That's the remainder right there. That's the remainder. When you subtract them, that's the remainder, right? 4 doesn't go into 2. That's your remainder. So remainder is 2. It corresponds to negative 1. That's the goal here, okay? So if you divide by 4, let's say an example that we're divide by 4 and you get a remainder of 0. If I have I to the 12th, if I have I to the 12th, that would be I to the 4 times I to the 4 times I to the 4. So that means 12 divided by 4 equals 3 with a remainder of 0. 4 goes in evenly. That's why the answer is 1. And remember, all these exponents of I to the 4th, each one of these is 1. Right? I to the 4th is 1, I to the 4th is 1, I to the 4th is 1. All right, so if the remainder is 0, then it's equivalent to just 1. So that's what this means. Now, what is this 0.25 business, 0.5 business? Well, most people really don't remember how to do remainder. Long division has been not practiced very much because of the calculator. So what we do is just look at what the decimal part is. So if you do, say, if you do 5 divided by 4, right? If you do 5 divided by 4, so let's say, let me do an example. I to the 5th. If I have I to the 5th, so you take that exponent, divide by 4, so it's 5 divided by 4, and you get 1.25. So you're looking at just the decimal part. If you look at just the decimal part, so 0.25 corresponds to just I. So then the answer is I. So I to the 5th is equivalent to I. I to the 5th is equal to I. Right? That's the weird part. It just kind of comes back to itself. If you need a little more convincing, I to the 5th, same as I to the 4th times I to the 1st. Right? And remember, I to the 4th is 1. 1 times I is just I. All right. So that's what that is. Okay. So we're going to do some examples that kind of lead up to it. All right. So the regular problems where we have to take the square root. And remember, you must deal with the negative signs first. You cannot multiply first. You must deal with the negative signs first. So this becomes 3i root 12 times 4i root 15. All right. And multiply it out. So that's 3 times 4 is 12. I times I is I squared. And then 12 times 15 is 180. All right. Now, what is I squared? I squared is negative 1. And by the way, I squared is the most frequent version of I you're going to see, because we do a lot of it where it just ends up being squared. All right. So that's going to be negative 12 square root of 180. And now, and notice there's no I left over. So that's a frequent case. When you have a problem that has I in it, it doesn't stick around. Right? Because look, half these versions don't have I in them. Only I to the 1st and I to the 3rd have an I remaining in the problem. Okay, so half of them don't have I in them. All right, so negative 12 root 180. So you still have to deal with the 180. So 180 is what? 2 times 90. 90 is 2 and 45. I'm going to have to go sideways here. I'm running out of space. 2 and 45. 9 is 5 and 9. 3 and 3. So there's a pair of 3s and a pair of 2s. Right? And there's a 5 stays inside. So that's going to be, let's go up here. So it's negative 12. 180 was, there's a pair of 2s, a pair of 3s, and there's a 5 left over. So that means a 6 comes out. So that's negative 72 root 5, right? 2 comes out, a 3 comes out. So that's 6. 6 times 12 is 72. So negative 72 root 5. That's what that is. All right, moving on to example B. There's an I. So negative 2I root 6, 3I root 10. Multiply. So that's going to be negative 6I squared root 60. And I squared is negative 1. So it makes the negative 6 a positive 6. So positive 6 root 60. And then 60 is 4 and 15, 2 and 2, 3 and 5. There's a pair of 2's. So that's going to be, a pair of 2's comes out, becomes 2 times 6 is making it 12, and then root 15. All right? All right. 15 comes from multiplying what's left, 3 times 5. Okay. All right, so these are the weirdo problems that we're going to ask you to do. I to the 29. You take the 29, divide by 4. I want to get 7.25. 0.25, go up here, look at the chart. 0.25 is just I. That's the answer. So that's equal to I. That's it. Okay? So I'm not asking you to rewrite it as I to the 28 or whatever. All right? Just look at the chart and you get that. So I to the 110. So you take the 110, divide by 4. That's going to be what? I don't know what that is. So I'm getting the calculator. 110 divided by 4. 110 divided by 4. And I give 27.5. 27.5. I have a decimal 0.5. Look at the chart. 0.5 corresponds to negative 1. So I to the 110. Got a miss here. I to the 110 equals negative 1. That's it. Right? 0.5 corresponds to negative 1. When I divide it by 110, when I divided 110 by 4, I got 27.5. So that means I to the 110 equals negative 1. Moving on. So I to the 31. So just leave the 12 alone. But then for the I to the 31, do the 31 divided by 4. That's going to be 7.75. 0.75 is equal to I to the third, or negative I. Right? 0.75 corresponds to negative I. So this I to the 31 is going to be negative I. So that's negative 12I. Right? I am replacing, think of it this way, I'm replacing I to the 31st with negative I. So I'll bring the negative forward, so it's negative 12I. That's how I got that, negative 12I. All right, F, do the same thing. I to the 120. 120 divided by 4 is 30, meaning there is no remainder, so it's gone, right? I to the 120 is equal to 1, right? Remember, when there's no remainder, when there's no decimal part to it, where'd it go? Here we go. Right? When there's no decimal part, it's just 1, right? The exponent is a multiple of 4. So I to the 120 is equal to 1. So the final answer is just 20. Because 20 times 1 is 20. Next one. Here, multiply 10 times 6 is 60. Then that's going to be I to the 16. Remember, when you're multiplying bases with exponents, you add the exponents. 16 is a multiple of 4. So that's going away. So it's just 60. F, we got... Multiply the regular numbers, 3 times 8, 24 times 10 is 240. Add the exponents, 10, 13, 19, so it's I to the 19th. Divide 19 by 4. 19 divided by 4 gives me what? 4.75. Right, so there's a decimal part of 75. That's I to the third, or negative I. So it's negative 240I. Right, 0.75 corresponds to this bottom one down here. So it's negative I. Negative I. So I just replaced I to the 19th with negative I. Whenever you have exponents with exponents, where'd it go? All right, so you raise the coefficient to that exponent. So it's 4 squared, or 16. But you don't raise the exponent to an exponent. You just multiply the exponent. So that's I to the 18th. Multiply exponents. So 18 divided by 4 is 4.5. 18 divided by 4 equals 4.5. And remember, 0.5 gives you negative 1, so it's negative 16. I to the 18th is replaced with negative 1, so I get negative 16. H, 5 to the third is 125. 13 times 3 is 39. 39 divided by 4 is 9.75. 39 divided by 4 is 9.75. Remember, 0.75, that decimal gives me a negative I. So this is negative 125I. And that's it for the imaginary numbers. I know that took a while and it was kind of a mess. I'm sorry. Have a good day.